So in this video, we're going to discuss the key features of quadratic equations. Quadratic equations are a little bit different than linear equations. They're going to give us a different type of graph. A linear equation gives us the graph of a straight line. A quadratic equation is going to give us a U-shaped graph that looks kind of like this, which we call a parabola. All right, it can open up like this, or it can open going down like this. All right. The general formula for an equation of a quadratic looks like this. It's y equals ax squared plus bx plus c. It's only a quadratic equation if the biggest x is x squared. All right. It has to be x to the second power, or if it's not, then it's some different type of equation. So every quadratic will have x squared in it. So let's go through all the different parts of the graph that you would see. You'll see that some of them are similar to a linear equation and some of them are not. So first we have a y-intercept. A y-intercept is the point where the function crosses the y-axis, or the point where the x value is 0. All right, this is the exact same as in a linear equation. So a y-intercept's no different than it is. It's where it touches the y-axis. When we're doing y equals mx plus b, the y-intercept's always the b. But in this particular situation, it's going to be the c number, because that's the number that's by itself. All right. And you can evaluate the function when x is 0 to find it, and the ordered pair is always going to be 0 for the x number, and then whatever the c number of the equation is. Next, we have x-intercepts. So if a y-intercept is where it touches the y-axis, an x-intercept is where it touches the x-axis. All right. And then the y value is 0 whenever you have the x-intercept. So if we were ever to do it mathematically, you set the y equal number to 0, and you can find the x-intercept by using the quadratic formula, which is something that we'll discuss later in another video. And the ordered pair when x is 0 is always the x number. The ordered pair is always going to be x, and then y is 0. Now for quadratics, and we did this with linear equations, whenever there's other terms that we can use for x-intercept. All right. X-intercepts can be called roots, solutions, or zeros. Zeros are something that we dealt with when we did linear equations. So the next thing that we're going to talk about is zeros. It means that it's the values of x that make y equal to 0. Now in a line, you're only going to have one 0. Okay, because since a 0 is an x-intercept, it's going to touch the x-axis only once in a line. In a quadratic graph, like the example I showed you earlier, you can see that there are 2 spots here where it touches the x-axis. So this particular one has 2 different zeros. There's going to be situations where we graph, and it's only going to touch one time like this. And then there'll be times where we have a graph that will look like that, and it doesn't touch the x-axis at all, so we could have 0. So there may be 0, 1, or 2 zeros or solutions to any quadratic equation. And in order for us to find this mathematically, we make y equal to 0 and we just solve. And again, we'll get into that more depth in another video. You can also factor out this quadratic equation, and then with the 2 factors, you make each one equal to 0, and then you solve for x. Another thing that we want to talk about with quadratics is the axis of symmetry. This is something we do not have in linear equations. All right. Axis of symmetry is an imaginary line that goes through the center or the vertex of the graph. The vertex of the graph is just the highest or lowest point, and that's something we'll discuss more in a second. The axis of symmetry is always an equation. It's always x equals some number. Whatever number it goes through in the graph is the x number that it'll be equal to an equation. Going back to the example that we used earlier, you can see right here this is the lowest point, so this would be where the vertex is. So if I drew like an imaginary line through here, you would see that it touches at x is where x is positive 3. So the equation of this imaginary line, or this axis of symmetry, would be x equals 3. Next, we have the vertex. And as I was just talking about, the vertex is the highest or lowest point of the graph. Here it would be this lowest point, whatever the coordinates were. So it'd be like 3 and 6. Here would be the highest point of this graph. So it'd be -5 and -2 would be the ordered pair of this vertex. The vertex is the highest or lowest point on the graph of a quadratic function. It's always an ordered pair. And then this is some way that we can find it mathematically. So the ordered pair of the vertex is always this little formula. One that we normally won't use because you can just use your eyeballs to see where it is on the graph. And then another thing that we talk about in quadratics that we don't when we're talking about linear equations is a minimum or maximum value. That's going to, minimum would be the lowest, maximum would be the highest. So depending on which way your graph goes, it's going to depend on what it's going to determine whether you have a minimum or a maximum. So the x value of the vertex is always the minimum or maximum of your quadratic equation. And this can be found using this little formula if we needed to do it mathematically. But again, it'd be easier for us to graph it, and since we have that ability, that's what we're going to do all the time. It's easier for us to graph it and then use our eyeballs to see where that would be. So let's put these terms into practice. So we're going to take this little example that we have of y equals x squared minus 6x plus 3. And we're going to identify all of these different things here. So the first thing is the x-intercept. Well, the x-intercept is where our graph crosses the x-axis. That's happening at two different spots on this one. It's happening right here and right here. So the x-intercepts are points. Points have ordered pairs, so there's going to be an x and a y value. So this one, the x value is between 0 and +1, so that's going to be +1/2 or +0.5. So when I write it out, 0.5. And then the y number is always 0 at the x-intercept because it's on the x-axis, and that y number is 0. And then for the other point, it's between 5 and 6, so we're going to call that 5.5 and 0. These are the x-intercepts of this particular graph. All right, there's two of them because the graph touches the x-axis in two different spots. Next, we want to find the y-intercept. The y-intercept's where it touches the y-axis. That is happening right here where y is 3. So our x, well, that's going to be an ordered pair because it's a point. So 0, 3. Very similar to a line. If this was a straight line going through here, that would also be the y-intercept because that's where it's touching the y-axis. Next, we have the axis of symmetry. The axis of symmetry is the imaginary line that goes through the center of the graph. And we talked about this a minute ago when we talked about it. This is the lowest point of the graph. So whatever the x number is of this lowest point, which you can see here is +3, that is the equation for our axis of symmetry. Just draw the line all the way through. So my axis of symmetry is a line. Since it's a line, we should have an equation for it. X equals 3. Next, we want to find the zeros. Zeros are the same thing as the x-intercept, which is the same thing as solutions, which is the same thing as roots. However, when we're talking about zeros or roots or solutions, we're only looking at the x number. The x-intercept are actual points, so they have an ordered pair. They're coordinates on the graph. The zeros are just like the answers or the solutions, so it's just the x values. So we already found the x values of the two where it crosses the x-axis, the two different points. So we're just going to write these x numbers as the solutions. So our zeros could be 0.5 and 5.5. Don't put any parentheses around it because it's not an ordered pair. We're just listing all the possible answers that work for the zero of this quadratic. Next, the minimum or maximum value. The minimum here, this is the lowest point, so it's going to have a minimum. If the graph was turned the other way and we had a highest point, then it would be called the maximum. But in this particular situation, we have a minimum. And this lowest point is at right here where the y value is 6. Okay, so that's our minimum. It's not an ordered pair because we're not looking for a certain point, we're looking for an answer. So the minimum value is going to be 6. Sorry, negative 6, because it's negative 6 on the y-axis. This is a negative. The vertex. The vertex is the ordered pair of the highest or lowest point. We already determined that this was the lowest point of the graph. So this ordered pair will be the x number and the y number in parentheses, 3 and negative 6. And that gives us our vertex. Now we want to talk about domain and range. All right. Whenever we have a quadratic equation or a quadratic graph and it has arrows that go on forever, the domain is always going to be all real numbers, right? Because this graph will keep going to the left forever, so we'll use all the negative x numbers. This side of the graph will always go to the right forever, so we'll use all the positive x numbers. Even if it was flipped upside down and going the other way, it would still go to the left forever and go to the right forever. So the domain of quadratic equations, is always all real numbers. Every single problem is going to be all real numbers. The only thing that's going to be different is when we're talking about the range. The range is all the y values. So the y values are going to be different. You see here in this graph, and finding your minimum or maximum value is going to help you. If it's a minimum, then it's all the numbers that are bigger than this. If it's a maximum, then it's all the numbers that are smaller than this, because minimum means that could be the smallest number, maximum means that could be the biggest number. So since we have a minimum, all of our y values, or all of our range, is going to be negative 6 or bigger. Any number that's negative 6 or bigger would work. And you can see in our graph, this is the lowest point right here where it touches. And if I go up anywhere on this y-axis, I can find a point on the graph. I can find one at 1, I can find one at 5, I can find one at 8. I'd be able to find one way up here at 20, because the graph will keep going this way. Okay? So again, if you have a minimum, it's always y is greater than or equal to that number for your range. If you have a maximum, it's always y is less than or equal to that number for the range.